now we are going to discuss about the technique, very important technique of circuit theory analysis, that is the Kirchhoff's current law. What is Kirchhoff's current law actually, and how it is being applied to different circuits? Today I am just going to tell you about the method and how to apply it. We will be able to solve different problems in different parts. I will be telling you different techniques how to solve these problems, but on the other videos. Okay, today we are going to just learn about the technique, how to apply it. Okay, now this technique, that is the KCL technique, this is having some conventions itself, and the conventions in different books you will find different conventions, but according to me my conventions are fixed, and that is very much fruitful to me till date, and it will be in future also. So if you want to follow me, then you just can rely on me, and these conventions are true actually. Okay, I am not having any false idea about it. Okay, now this thing, the KCL, if we are saying that a circuit is given to us, say this is the circuit, it is the same circuit that we have taken for the KVL also, the same circuit I am taking for the KCL. Okay, then this will be easier for you to understand, and the same problems can be solved by KVL and KCL, just the barrier is that the time. Now this is my circuit. Whenever we are applying KCL, we have to know the basic funda of it. What is that? The fundamental aspect of KCL is, in a node, if we are having different currents entering and exiting from the node, say this is my I1, I2, I3, I4, I5, then what we can say, the total summation of the currents at the node, the summation of the current at the node is equals to 0. That is the KCL law. Now, some currents are entering and some currents are having an exit from the node, and my convention is that if a current is entering, give it a negative sign. When the current is entering, give it a negative sign. Again, I3 also entering, give it a negative sign. What is exiting? Give them the positive sign. This will be equals to 0. Then what we are actually calculating? The number of currents they have entered is equals to the number of current that they have an exit from the node. Okay, this is the principle of KCL. Now to apply the KCL to a circuit, we need some ground rules. The ground rule is that we need to put a reference node on it. And what we know about reference node? Reference node can be a junction also. It has to be a junction. Junction means, what do you mean by junctions? Actually, these can be elaborated in my other circuit theory classes, but today I am just briefly telling you that junctions are the nodes which are actually having two or more elements connected to it. Then what is node? Node is one or more elements connected to it. Means this is a node because this voltage source, and this resistance are connected to this. This is a node because these three resistances are connected to this. This is again a node because these two resistances are connected to this. But all the nodes are not the junctions. Junction means two or more elements has to be present. Means what? This is a junction. We can have this to be a junction. This is R5, R4, R3. There are three connected in this. This can be a junction. R1, R2, R4. They are connected to this. For the reference node, what we need a junction to make it ground. Now, you can take this to be your ground, this to be your ground. But the voltage source's negative portion is actually of a lower value. That is why this node, if we make it ground, then this will be much more easier to calculate. And low potential, ground, they are more or less similar to each other. That is why we can say this, make this ground. Okay, let's just make this ground. Now, whenever we have this ground terminal present, now we have to calculate the currents entering and exiting to a particular node. And which will be that node? The other junction present in the circuit. Then that is what? Say this one. Say this is V1. The potential of this node is taken to be as V1. Now the current which is coming outside, that is I1. The current which is going in this direction, say that is I4. Say this is I2. Say this is I3. Okay, then this is coming I1, I3, I2, and this will be again I1, this will be I2. Now, if someone is asking me to have the relations in this circuit via KCL, then what will be it? Say, this is a potential present here and we are having another potential here. This is another potential. Then, the potential difference divided by the total path resistance, that is R1 and R5 in this path, this I1 path. Okay, that has to be giving the current I1 itself. If we just write it here, this is I1, this is I2 and this is I3. So what we can write? I1 is entering the node, that is minus I1. I2 and I3 are exiting the node, means I2 plus I3 is equals to 0. Now what we can write? I1 is equals to I2 plus I3. What we are actually going to do now? We have to replace these currents via the voltages. What are they? This is my voltage here V, this is my voltage here V1. So what is the potential difference? V minus V1, because the current is going from V to V1. That is why I am writing it like this. Divided by the total path resistance. So that will be R1 plus R5. Because in the path of I1, there are two resistances present. That is why the series connection of them is taken to be as the net resultant resistance. Is equal to the potential, the current of this, that is the potential difference will be V1 minus 0, because the ground is here, divided by R4, sorry, that is the I3, and this I2 will be plus V1 minus 0 divided by R3 plus R4. As you can see from this, what you can see, only one variable to be unknown, because R1, R2, R3, R4, they will be all known to you. Okay, this is R2, sorry, this is R2. Okay, now if you know every parameter other than V1, but by just calculating it, we can actually calculate the value of V1 itself. If we know V1, then it will be very much easier for us to calculate any of the current, any of the potential differences of the circuit. This is the basic principle of applying KCL in any of the circuits. You just have to understand this and follow the steps. Any circuit can be solved. In case of AC also, you can apply this principle, and that is a bit different, bit difficult. I will be telling you on other classes, but for today, this is the application trick or technique that you can say for applying the KCL to any circuit. Thank you for watching this video. If you like this, then please subscribe to my channel. It will be beneficial for you. I will be uploading this kind of videos really soon enough. Thank you.